there, and welcome to Note Card 32, Local Extrema. In Note Card 31, we should have learned what Extrema was. So if you don't remember, look back at your notes. Extrema is minimums and our maximums, our collection of them. In last video, we learned about global or absolute extrema, the very highest and the very lowest. Today, we're going to learn about a different type of extrema that are minimums and maximums that happen within your graph. So we can have multiple of them, and I'm going to show you what that looks like. So we've got a graph here. I'm going to make the graph of some random polynomial, like this, and I'm going to switch my expo marker because clearly that one's dying. So we have this graph here. So our definition, according to our note card, says let C be an interior point of the domain. So that just means some point on the inside of the function f. Then f of c, so that point, is a local or relative maximum value if f of x is less than or equal to f of c. So all that means that if the whole graph is below the point, or in other words, the point is a highest point in that interval, then it is some kind of local maximum value, right? For a local minimum, if f of x, or the graph, is above the point for all x in some open interval, then it is a minimum value. Okay, so that is a fancy way of saying this. It's something that we're very used to seeing. Basically, all of our local maximums are going to be points that look like hills. So anytime you see some kind of a hill or a peak on your graph, that is a local maximum. So I'm going to be looking here, like here, see this hill shape, right? This right here would be a local maximum because close to it or around it, it's the highest point of everything nearby it, right? We have two other local maximums, so see if you can figure out where you think they are. Got it? There is one right here. This other hill shape is a local max or a relative max. That means the same thing. And then this one here is also a hill shape, a local max. Okay. Then we've got to look for our local minimums. Our local minimums are things that look like valleys. So this kind of U shape here, again, because this point is the lowest point in its local surrounding area. Like if this was a neighborhood, it is the lowest point in its neighborhood, right? So we've got a minimum, a local minimum, and then we've got one more somewhere. You got it right there, a local minimum, okay? And then let's review, throw it back to last one. We can only have one absolute max and one absolute min. So take a guess at which one would be the absolute max. This one here, right? That is your very highest. And then your absolute or your global minimum would be this one down here, right? So this is your absolute and this is your absolute here. Okay, so we can have more than one local maximum and more than one local minimum, which as a group we would call local extrema. And then we only have one absolute max and one absolute min, right? Like that word absolute, there's absolutely one of them. There has to be one highest one and one lowest one. All right, so we are going to practice doing this using these right here. If you have a graphing calculator handy, grab it and do this with us. Because we are going to use, see where it says calc here, that means calculator, not calculus. This is all calculus, okay? So grab your calculator, and I'm going to do this with you so you can see how I use my calculator. So it is on and it is cleared. And my function here is 9. Okay, I'm going to be really careful here putting this in the calculator. I want my denominator to be 1 unit, or sorry, my numerator to be 1 unit. So I'm actually gonna put this brackets around this when I put it in the calculator, just to make it really clear to my calculator what I'm doing. So I'm gonna go to y equals, and then clear out my last one, and I'm going to use parentheses. Sorry that I'm moving this, I can't really see it. I should think of a better method for this. Still new at this, right? X squared minus 3. So I'm gonna close that set of parentheses and then close the numerator. Divided by, we want x to the third, okay? And then I'm going to press graph. My window's a little off from the last time I used it. Notice they don't specify an interval, right? I just want to see it as a whole. So I'm going to go to zoom standard, zoom 6, and see what happens there. Okay, so I'm looking for any places that kind of mimic either a hill or a valley, a local min or a local max, right? So my local min here